Now we'll look at the best case scenario. This is where we're going to be treating the virus with medication, and we'll see how the population reacts with the numbers react with that treatment. All right, so on your Canvas questions, the first couple questions just come directly from the text, but then on this one, you're supposed to write an equation or a formula for the number of doses that can be produced of the medication each day. And so we're adding the same amount each day. We know we can add 1,400 doses every day. So this is an arithmetic sequence, where we're adding the same amount each time to go from one term to another term. So the basic form of an arithmetic sequence says that the nth term of the sequence is equal to the first term of the sequence plus the value that we're adding for each term times the number of times we've added it, which is always n minus 1. For example, if it's the fifth term, then we've added that value 4 times from the first term to get to the fifth term, so times n minus 1. Okay, so if we look at the sample problem that Ms. Rose gave to us, she basically has this problem worked out for us right here. We've got a sub n is a sub 1 plus d times n minus 1. So for our problem, the a sub 1 is the amount of doses on the first day, which is 327. We know we've had 327 for days 0, 1, 2, and 3. But then we're going to be adding 1,400 doses every day. So the number of doses we'll have on any given day will be 327 plus 1,400 times the number of times we've added the 1,400. Well, since we're not adding until day 4, day 4 means we've only added 1,400 one time. So it's got to be d minus 3, the day number minus 3, since we're up through the third day, we weren't creating any medicine. So d minus 3 times 1,400. Okay, so that's basically the same for you guys as it was for the sample problem. All right, then you go on to question number 3. How many doses are available to administer immediately? How many patients are affected on day 3? And then use your answers to 3 and 4 to determine how many would remain on day 4. So on the sample problem, you see that same thing is answered here. We have 327 doses available immediately to administer. On day 3, we know that there's 768 people infected with the virus on day 3. So the number of people infected and undosed would be the 768 people infected minus the 327 doses that we have, which should be 441 people remaining undosed on day 3. Okay, then we're asked to complete this table, and so a good portion of this we've already answered, or we can answer very quickly. We just answered the doses administered on day 3 was 327, and so the infected but undosed people was 441. So let's look at the sample problem again here, and we can see that, okay, so we had, here's the 327 doses available on day 3, leaving 441 people undosed. So then for day 4, these 441 people remaining undosed will all infect 4 more people. And so we'll have 1,776 people infected on day 4. We will create 1,400 doses of the virus that day. And so we can treat 1,400 people. So 1,764 minus 1,400 is 364 people that are going to be remaining undosed on day 4. So then all of those 364 people will infect 4 more people, leaving us to have 1,456 people infected on day 5. 1,400 doses again on day 5, so we'll end up with 56 undosed people. By day 6, then, we only have 56 times 4, which is 224 cases. We'll be able to treat all 224 and have plenty of doses left over, and so we'll end up with day 6 with 0 people. So this says, based upon the information above, were you able to eradicate the disease after 6 days? And yes, we were. We were able to get rid of the disease, and we could see how many people actually ended up contracting it. Okay, so that gets us through question 6. Question 7 is the same question we just answered there. Question 8 asks for a recursive formula. So a recursive formula shows how any item in a list relates to the previous item in the list. So we can calculate any current item in the list by using the previous item. So the current position A sub n is equal to the previous one, A sub n minus 1, plus some common difference between the two. All right, so if we go back and look at the sample problem, this is also done on the sample problem. Okay, so we're saying the number of untreated people on any given day will be equal to the number of untreated people on the previous day plus some constant amount that's added each time. Well, for us, the number of people treated on the previous day times 4 is the number of people infected. But then since we can treat 1,400 of them each day, then we could say the number untreated on any particular day is 4 times the number untreated on the day before minus the 1,400 people that we were able to treat. And so we can then use this formula to calculate the number untreated on any given day, knowing how many were untreated on the day before. Okay, so that takes us through all the questions on the best case scenario. So hope that helped you through that, and good luck.